Hello and good afternoon. Welcome to ET Auto Virtual Roundtable on Reimagining Mobility Design Digital. This roundtable is brought to you by Tata Elxsi. As we talk about the global megatrend of CASE, connected, autonomous, shared, and electrified mobility, there's a hell lot of things that are going to change the way we design and develop mobility products, be it passenger vehicle or commercial vehicle or any sorts of mobility product that is in for a mega shift. To discuss and reimagine how will the future of mobility look like, I have an esteemed panel members who are the stalwarts in their respective segment of the business in entire mobility business value chain. Let me introduce Mr. Samir Yajnik. He is Executive Director, Electric Vehicles. We are also joined by Mr. Shashank Srivastava. He is Senior Executive Director, Maruti Suzuki India Limited. And also, you know that Maruti Suzuki India is India's one of the biggest, or you can say the largest, easily the largest passenger vehicle manufacturer. We are also joined by Mr. Mahesh Babu, CEO, Switch Mobility India. And we are also joined by Mr. Nick Talbot. He is Global Design Head at Tata Elxsi. He joins from London Design Center that belongs to Tata Elxsi. Thank you so much, gentlemen, for taking out time and joining this pertinent virtual roundtable on reimagining mobility. My first question is to you, Mr. Nick. Just want to understand for my Indian audience how the things are shaping up as we are rapidly moving towards future mobility with electrification catching up very fast around the world. So how do you see, what are the mega trends do you read, and what are the way forward that the people are trying to reimagine the future mobility, and what all will trickle down to markets like India? Over to you, Nick.
Sure, thank you very much. I think the first thing to say is that we're all witnessing a really exciting and fairly extraordinary transformation, as you say, not just in passenger vehicle, but across every type of mobility. So from rentable e-scooters, micro-mobility solutions in our urban centers, all the way through to, for example, the setting up of a hydrogen highway across Europe, mainly to provide fuel for long-distance trucking. So all of these themes are affecting every form of mobility. Of course, electrification is actually pretty extraordinary. Every week I read about some new battery chemistry, the kind of range that we can get from contemporary vehicles, especially when we factor in issues like lightweighting. So the change is happening very rapidly across Europe, to an extent the US, and of course we shouldn't forget the enormous e-mobility market in China. But I think there are a couple of other elements that are contributing to this. So the first is ever higher levels of automation, both within cars but also in commercial vehicles. We're also, I guess, seeing much more intelligence within the vehicles. So that's transforming the way that people experience both public transport and vehicles themselves. And finally, the emergence of much more sophisticated digital ecosystems. So all vehicles are much more connected. The kind of networks that will let you book a vehicle, decide which vehicle you want to buy is much more advanced than it was even a few years ago. And I guess the final point is, from a design point of view, the emergence typically of a so-called skateboard chassis, whether that's for a car or a bus or a truck, is changing the overall vehicle platform. It's generating more interior space. It's giving designers more freedom, I think, with both the exterior and the interior of the vehicle. So those are some of the key elements, I think, that are driving positive change across all vehicle typologies. Of course, there are some challenges and there are some barriers, which I think we'll probably discuss in this session, mainly around consumer perception of electrification. Today, there are some issues with cost, but ultimately it's believed that in the end, an EV vehicle will end up being cheaper to buy and certainly easier and cheaper to run than a conventional ICE engine vehicle. So those are the key factors that we've got our eyes on that I think will continue to change the way that we access mobility. Obviously, as we move towards ever higher levels of automation, we will ultimately see fully autonomous robo-taxis, and that's going to change the way that we book our journeys and the way that we experience our journeys. So those are my top 4 or 5 drivers of this amazing change that we're witnessing.
Thank you, Nick, for putting it so elaborately. It looks like the transformation is all around and it's massive, very complex. Look at the high-level points that you made here. That's from the powertrain, like is it going to be electric powered or ICE? How much will it survive? Even in type of the vehicles that we make today, like passenger vehicle, buses, trucks, and all that, with micro mobility and multi-level mobility, how will these shapes of the mobility solutions going to change with shared? What will be the thought process of the users, because they will probably like to have completely exclusive ride experience or driving experience. So looking at all this, Shashank ji, since you are currently representing India's largest passenger vehicle company, and you understand that passenger vehicle is at the center of entire value chain that we have in mobility when we talk about transporting people, especially in India, which has largely personal mobility as one of the focus. Just want to understand, since the topic and the theme of today's discussion is design digital, so how much do you think when you go to your drawing room or boardroom, how much of digital implementation you are looking at to find a solution to such a complex transformation that is happening? This is not that one part of the vehicle is going to change. It's entire all-round change that we are going to see, the shape of the body, to the powertrain, to everything, to the way users used to use it. Everything is changing. What are the biggest concern? What are the biggest fighting point that you have with your R&D team, and how much solution does the digital part plays there?
Thank you, Nabil, for having me in this discussion. First of all, I think it's the entire ecosystem that we need to look at when we look at the transition to a new e-mobility, as we call it. And the biggest stakeholder, obviously, is the consumer himself or herself. One of the key trends which we find is that the digitization, while it is driving disruptions, it's also increasing consumers' desire for immediacy, for personalization, for convenience of all those things. And I think that is the prime driver of this change, and that is being enabled by technology. And for example, when we talk of high personalization or AI, for example, it's moving beyond automation. It's moving, it's evolving into changing buying experience of the consumer itself. In fact, I think Nick just talked about the ownership pattern of passenger vehicle itself is changing. So it's not just about the product or the design. People, for example, might be looking at pooling, maybe looking more positively at subscription or shared mobility. That is being enabled by technology. And then, Nabil, when you talk about it's not just about environment. That's government which is involved in the entire ecosystem, and we can talk of suppliers, we can talk of the government agencies, we can talk of OEMs. We talked about consumers who are affected both by vehicle performance, which the new age vehicles enable thanks to the technology. You talked about the design changes and what we fight for when we talk to R&D guys. I think you will see a huge changes in design. For example, while today many of the manufacturers trying to fit the ICE vehicles with a battery powered thing, so more or less design remains same, but it's not really efficient. So probably we'll have dedicated EV platforms. And that's what we are seeing with most OEMs now. So gone is the age when we looked at the car, designed a car, and then we say, oh, for the powertrain, let's see what we can do for the electric, for the battery vehicle, powered vehicles. So we will probably see dedicated EV platform, and that enables more space. I mean, it's a customized vehicle design. There is, in fact, for EVs, there's no floor hump. So you could actually have a much better design, more trunk space. You also can see, for example, people moving away from the old type of architecture to absolutely new ones. I just mentioned. In fact, you could see also from the supplier side a lot of component value share shifting from engine to battery. So it's estimated, for example, in the current ICE vehicles, while about 35% of the total value share going to the powertrain, which means drivetrain or transmission or fuel supply or engine, shifting to more of a drivetrain transmission with the electric engine. So it's like estimated almost 43-45% will be shifted to that as far as the component value system is concerned. So you could have so many other changes. We talk about steering by wire. So you don't have to have a physical interaction between steering and the wheel, but you could have electric power, electric motors doing that. We talk of energy recuperation, even 360-degree. We really talked to our R&D whether 360-degree steering is possible for very ease of parking in tight spaces. We could see more digitization leading to such factors like looking for a parking space, for example, or finding a charger nearby, or including, for example, if in a connected cars, you could find out if you are driving, leading to more safety, what are the weather conditions going on an online basis, and it changes the experience completely. We are fighting with R&D, for example, to also introduce consumer experience connection, what we call C2X, which is connection to everything, including that helps consumer get a different experience as far as entertainment is concerned, or connection, or even safety in many respects, should you have some sort of an accident. So I think the whole thing will change and design will change according to the ecosystem, and we'll see a huge shift going forward as the adoption of this new mobility comes true.
Shashank sir, one question before I move to Samir and Mahesh. I just want to understand, when you go to boardroom and design a vehicle of future, or we just want to imagine how does the vehicles will look like, how much of the current shape, how much of the current features, how much of the current utility that we have, that will continue to exist.
Yeah, so I think we'll see more electronics and more connectivity. So you will have all the advantages that you can have if you have a real real-time connectivity. It, as I just mentioned, it leads to a lot of safety. It leads to a lot of good experience, and including entertainment, for example. So all that will change, and space maximization and space utilization can. It's much more. As I said, there is no hump in the on the floor, so you can actually design the space utilization in a much better way. You could see, for example, if you have self-driving cars, you could see a totally different seating style. The imagination, you can imagine as much. And I think while today the EVs still which are getting into the market still have the traditional top hat, the exterior architecture, but going forward you could see an absolutely different way of utilizing space, because the platforms of EVs actually allow you to do that.
Thank you.
Absolutely.
I'll come back to you again. Mahesh, I just want to understand, we are talking about multimodal mobility. That means there are going to be some micro mobility, some vehicles that will connect to shorter distance, some vehicles will be used for longer distance, intracity, intercity, and all sort of scenario. Just want to understand, for a bus manufacturer, electric bus manufacturer, what are the biggest problem that you are going to solve? Because currently all the transition is happening, and there is a reason at the background, that is pollution, congestion, safety. These are the top three reasons for which we are working, and this is on the background when we are reimagining the future vehicles. For buses, how much of change do you see, and how does it help using digital tool to design those vehicles? How much of work happens there?
Okay, Nabil, thanks for bringing me here. I agree with Nick and Shashank, what they have talked about. I think we are going through something very, very transformative in auto industry, which we have not seen for 100 years. Just want to set the context. I think you talked about consumers, and India is very unique. And India, many ways surprises us when what we think and what consumers adapt. Today, for example, almost a third of the consumers are willing to buy electrified vehicles, whereas it was very low number a few years back. And almost 50 to 60% of the people today are conscious of the climate change and the net zero carbon emissions and other emissions in the cities, while they take a decision on buying mobility vehicles. So there is a substantial shift happened on the consumer front. On the adoption of EV, while we talk about that there is a change, as you rightly said, India is a completely multimodal transport. We have large two-wheelers, three-wheelers, four-wheeler cars, and buses. Mass transit adoption, like your metros and buses, play a vital role. All of us thought that electric vehicle is technologically advanced and very technically sound and knowledgeable people will adapt. But always India surprises. What happens today? Today, the largest adoption happens in three-wheelers, who are a very, very bottom of the load pyramid customers. Drivers are from rural India, and they are adapting faster, because I think that's where we'll have to look at where the adoption goes. Similarly, we all said that STUs are the last thing who can adopt electric vehicles, because they will not understand electric vehicle. If you look at bus adoption today in electrification, STUs and the government of India is at the top of the list. And they single-handedly drive the adoption of electric in buses when compared to private operators. And you know that two-wheelers are still about 2% of adoption, and the cars are less than 1% of adoption. So the major activities are happening between three-wheelers and the large government purchase of buses. And slowly we are getting into even private players are coming and trying to play a vital role in the bus segment. So what we think and what we adapt, I think there is a huge learning in Indian market, and then it's sometimes very simplified and a very intellectual level, but on the ground, the reality is something different. Even the cars adoption on rural India is much faster than what anybody could think. Electric cars, I mean. Could anybody could imagine, because I've been in the industry for 8 years. I did my electric car, three-wheeler, everything. Now, there is always a surprise from the market. Now, how digitization can play a role? For example, we have a switch ion connected mobility solution. We actually make solutions of the size of the battery, the number of seats, the number of charging station, where it should be located, completely through the connected mobility solution. And we literally can give a solution for the same customer for two different routes with two different configurations. So that is the power of digitization and connectivity we can do. And this is about total cost of ownership. So in commercial vehicle, it's important that you achieve the best total cost of ownership to make electrification more economical. And that's what we can do by connected mobility solutions, which with our switch ion platform and other connected solutions we have. Digitization, we talked about how can we configure the vehicle better. I think since I've done work from three-wheelers till buses now, I can tell you from the engineering perspective, from electrification, we can get between 8% to almost 28% additional space to a consumer or a customer by if you do a clean sheet design for either a car, depending upon the form factor between three-wheelers, two-wheelers, cars, and even buses. So it completely changes the perspective and utilization of the space, utilization of energy, and then give different customer experience in the form factor which we work upon. I think, but it will take a little bit time. You all know that Shashank said that right now we are only electrifying existing products. When you have born electric vehicles in all the sectors, then this optimization evolution will start, and that will really give consumers a much higher headroom and what I would say experience when compared to what we are doing today. But I would say we are in the right path. I think we have to learn a lot on the segment. We have learned a lot in last decade. I think all of them are being what I would say, plowed back to the products by the industry. Government is constantly tweaking policies like FAME2 to make sure the adoption is better. Now we are seeing every sector, almost there is a substantial adoption of EV in India. So I think it's a very dynamic market, both in policy, technology, as well as consumer behaviors. I think it's the best place to be in right now.
Thank you, Mahesh. Samir, I'll come to you. You have been at the both end of the business. You yourself have worked a lot in the digital space in terms of designing vehicles and other parts. Just want to understand the current scenario. India has faced a lot of Indian EV ecosystem has faced a lot of challenges. Vehicles catching fire. Just want to understand from your experience what will work in India. Where is the gap? Why are we seeing so many mishaps in terms of fires? Are we not adopting the right design methodology? And how much of digital can help? Because we are rolling out product very faster because the consumer behavior has changed. They want a new model every quarter sometime. I see some companies are going to do that and they are working on it. So just want to understand how do you see the various chemistries, battery chemistries working as we move towards the electrification in India and other markets, and how will the correct design format will help in terms of ensuring safety concerns that we have.
Thank you, Nabil. Thanks for the question and thanks for having me. As you probably know, Electra EV has rolled up its sleeves right from the early days when the EESL tender came along. And we were practitioners. We call ourselves pragmatic practitioners of technology, where we allow the confluence of technology to work with the real needs of the customers now and in the future. So we're working with OEMs, we're working with end users to not only build the right platform for what the specifications are today, but also driving them towards where they need to go in terms of maximizing range, maximizing the power efficiency and the energy required per kilometer, and also the right technology so that these are robust technology platforms or EV powertrain platforms that can survive, a lot of usage. So India, very interestingly, I think Mahesh mentioned, and so did Shashank, that India has surprised. Actually, if you dig deeper, India always follows a pattern of maximum, business case application and efficiency, which means that today the movement from EV, the movement that the EV world is facing, which is a huge demand post the pandemic, is really driven out of a business case. In the fleet segment, where we are very active in the four-wheeler segment specifically, and now going to the three-wheeler, it's no surprise anymore that over a 120-kilometer run, you get actually 12% more return on your investment in an EV compared to an ICE. Now, and so a lot of corporates, a lot of companies are switching to massive numbers of EVs that we are suddenly having to work towards. But your question was in this massive adoption, and whether it's coming by a government push based on FAME 1 and 2, or state policy, or whether it's driven by the Gen Zs or driven by fleet. Ultimately, these have to be robust platforms. And what are we doing about technology to make these very, very robust? First and foremost, the adoption to these vehicles have been somewhat rapid in the early years. So I agree. I'll call them Gen 1, Gen 2, Gen 3, and Gen 4 platforms, and I'll refine them in a minute. But they've been somewhat done with a bit of compromise. I would call it compromise, but the digital verification, planning, and reporting at design stage, because it was done, with some modification of existing ICEs, there were a lot of unknowns, particularly because most of these battery systems or battery boxes and cooling systems were being imported. We still import cells. Thanks to the PLI schemes, we're going to see a lot of indigenization there too. But the marriage between a battery management system and your cell is a critical function. The integration elements of your battery with your traction system, and how you regenerate some energy, or you get back energy whilst braking, is a fairly complex exercise in which you don't want to compromise on any thermal issues that might pop up. And you've got to, even today, the certification bodies and authorities are discovering that critical elements of safety can be introduced. For example, smoke detection and sensors that will allow us to understand where overheating is happening, etc. So there's a lot we're learning from these early adoptions. And India is always taking pragmatic steps and strides actually towards electrification. But we are at the front end and at the forefront of ensuring that any technology we use is properly tested and validated. The DVPRs are not compromised. Extra sensors are put so that we do not compromise ever on any thermal runouts or any kind of heat situations. And mostly it's heat, but also there are the Himalayas to drive at, etc. So you want to look at both those conditions, and they're very different requirements, by the way. And so all these in a complex maze of the new technologies that are coming in, because it's not just one kind of LFP batteries. NMC batteries are there. There are also fuel cells that are coming up, both hydrogen as well as aluminum air batteries are coming in. So in order to do all the permutations and combinations, but not compromise on any, both digital and physical validation, is critical for an OEM. And I spoke about Gen 1, 2, 3, and 4, and I'll quickly define what I'm saying. Basically, the first generation of EVs was, yes, retrofitted for scale. Not for just one or two cars, but they were retrofitted, but for scale, so that you could sell tens of thousands of them. The next one is energy optimized generation 1, which we call Gen 2, where you're still looking at maximizing the range for an application, but you're looking at how you can, completely optimize your energy that's used. Gen 3 is going to be what Shashank and Mahesh talked about, which is essentially designed for EVs, and designed for maximization of space. And Gen 4 is going to have all your customer experience based interconnectivity, V2X, all the entertainment systems thrown in, which you already have in some of the vehicles overseas. So I think, and then of course, safety through V2X, vehicle to pedestrian, vehicle to infrastructure, vehicle to vehicle, and vehicle to actually your grid. All that integrated into the system. There's going to be lots of electronics. So that's going to be your fourth generation. Very exciting times, but that's in summary of not compromising on your design process ever.
Indeed, Samir. Nick, I would like to bring you in here. You have seen that the OEMs have a lot of pressure in terms of rolling out product faster than ever. Earlier, the time to market was almost about 3 years. It is reduced to 2 years, and now even lesser. Some of the minor modifications comes as early as 3 months, 4 months now. In such a scenario, when we talk about designing a vehicle or for a full model change or a minor model change, how much of digital is helping? How are you trying to help these customers, OEMs?
Yeah, well, listening to what all of the other panel members have said, it's clear that the levels of complexity, so as you said at the beginning, it isn't just a single element to do with the vehicle platform, suspension, critical safety systems. There are also changes in battery chemistry. Our engineering teams do a lot of work in battery packaging, battery management systems, managing heat and cooling. Excuse me. And one of the critical elements is the kind of digital tools that we've got available to us. Number one, to look at quite a number of different options towards that optimization of the overall vehicle package. It also allows us to do much more simulation, whether that's structural or thermal, aerodynamic. So all of these digital tools mean that we can, on behalf of our customers, we can look at more options. We can ensure that all of those systems are tested. So a big part of what we do as a company is software testing, physical hardware in loop testing. All of these processes that have been established mean that essentially we can minimize the time to market. But as Samir put made the point very well, there can be no compromise on safety, whether that's the battery system, whether it's structure, and whether it's crash. So design digital simply means that we can meet our customers' expectation to deliver the right quality, but in the kind of timescale that's being driven by the market, because the market wants new vehicles, they want fully optimized vehicles, and they want EV fast. So those are the kind of tools that we've got available to us.
Thank you, Nick. Shashank-san, I'll come to you once again and understand. We are talking about personalization for each occupant of the vehicles. How do you look at this, and how tough or easy it is to provide a vehicle that will have personalized experience for all 3, 4, 5 occupants of a passenger car? How easy it is to design, how much tough it is, and what are the tools you are using to simplify these complex design elements?
Yeah, so I think overall the technology is available by which you can actually personalize, not just for the driver or if not the driver, the principal user of the car, but also for other occupants as well. In fact, when you talk of digital services, I think enhancing consumer experiences, generally in the industry, we look at about 3 layers of car user experience, and that's applicable across to all occupants of the car. The first level, of course, is vehicle-centric services, like, for example, predictive safety or predictive maintenance or things like that, which are considered today a very high level, but it's actually over a period of time with technology coming through with good connectivity, including the computing technology that's available. It's sort of easier. You could have the second layer, which we call the V2X digital services, which basically could be like I mentioned earlier, smart parking or infotainment. You could have location and navigational services. And the third level is what is called mobility as a service, which means that you can actually provide different consumer experiences, shifting away from privately owned modes of transportation to something which is like mobility or transportation as a service. These are the 3 levels which are possible in the consumer experience, if you see across. And industry looks at it in those 3 layers. For example, we talk of layer 1, which is the vehicle-centric feature. You could have an assisted and augmented driving. We are already into those phases where you have great assistance and augmentation of augmented driving, which is possible. The intelligent driver assistance system, which is being currently, the technology which is being developed very fast, very rapidly. You could have predictive safety. Actually, including driver fatigue, you can actually have retina movement online, and AI tells you, the analytics will tell you that the driver is fatigued or, there is a stress detection. So you can actually add safety, or whether it's lane keeping or pedestrian detection, onboard diagnostics, and all those things. Those are the level 1, layer 1 of personalization that is possible for people who are in the car. You can have a layer 2, as I said, which is V2X. Infotainment comes immediately to our mind. Location-based, you could have a route search, you could have downloads or traffic or weather information en route. You could have red light information, even radar detection. You could have remote control, security and maintenance as well. It's possible. And of course, the third level, which is the mobility as a service. And on work, I think on all these 3 layers is going on parallelly, and you could have a very good experience for not only the person who is driving the car, or in case of an autonomous car, a person who is the principal owner or principal occupant of the car, but for everybody else as well. That's quite possible, Nabil, and we are moving towards that.
So you think all these features will be easy to adopt in electric vehicles, and you think the space management can also be better in EV?
Absolutely, because it is moving parallelly. It's not as if EV is a technology all other technology then fit into this. All technologies are progressing, including, I think Nick mentioned how the cell technology or the battery, the fuel chemistry, the cell chemistry itself is changing. So all these things are happening in parallel. And because of the progress in one part is actually helping the progress in the other part. So the adoption of EV or technology or digitalization, or for example, technology, AI, or the immersive experiences, VX, etc., they are enabling you to think of progress in other fields. And it is all getting together. It is not as if EV is progressing, therefore you are getting progress in other technology. All technologies are progressing and coming together. And that is the beauty which you will see in transportation. And we are discussing today transportation. We might as well discuss something else, streaming or homes, connected homes. You could discuss and have topics of discussion something else. So everything is progressing parallelly, and I think EVs definitely enable, as far as architecture is concerned, to have a much better utilization of this technology, because essentially it's digital technology which is being incorporated in transportation.
Thank you, Shashank sir. I'll come to it. Was really tempting to hear all those features that will come. I hope very soon I'll have a car that will have all these beautiful features, and I'll be driving around Indian cities. Mahesh, I want to come to you. We have seen in some segments of electrification where two-wheeler passenger cars, we have seen a lot of issues coming up, especially related to the battery range and also the fire. Looking at all this, what has been learning for you when you talk about commercial vehicle like buses? You have done three-wheeler, now you're doing buses. How is it going to be different? Because this is a public transport that is completely different from three-wheeler, which has 2, 3 or 4 occupants, but here you have multiple occupants. How are you going to implement all those personalization? Do you think it's time for us, or when do you see it will happen in India, where all these public transportation can allow users to have personalized experience, as Shashank was mentioning? How much of effort it requires at the designing table?
Yeah, Nabil, I think you said the responsibility of a public transport in terms of safety, security, and many others is much higher when compared to anything else. I think that's the learning. If you look at the switch bus, we have 4 layers of safety. We have at the module level, we have at the pack level, and we have active cooling to make sure it has every safety. We have a connected solution where it constantly monitors the cell and the safety and the performance of the cell. On top of it, we give fire detection, safety, alarm, and also sometimes we give fire suppression system where it actually suppresses if any fire coming in. So we have 4 levels of safety, which is designed, and it's also implemented in all the vehicles. I know the safety issue of battery is one of the important and significant topic being discussed both at every level, at industry, at engineering, at media, and at public spaces, because it's a very interesting topic. It's important that it is addressed. See, any new technology which is coming is going to have some challenges. We need to overcome all the challenges, learn it, and quickly implement it. This can come due to what Samir has talked about, some of the challenges in validating clearly, and also some of the challenges in understanding the application of a particular vehicle, which nobody has envisaged, and then it comes in. So there is a kind of constant learning happens through it. And the good part is India has so much engineers. I'm sure somebody would have digged deep into it and found a solution of what happened, and we will quickly come up with a solution. Now, this happens in any new technology. Comes in when mobile came in, we had some challenges. First, we had physical challenges, then that was addressed. Then you have software challenges. Now we have software upgrades, bug fixes keep coming in. So a continuous improvement is part of life, and it's part of the auto industry. It's part of any new technology. I strongly believe all the challenges we faced during the application will be overcome soon, and we'll get into the next level of going in. Design and process is very important. I think all the learnings which are coming in field are fed back into the design process. You all know auto industry is very, very tough on design for failure analysis. We have DFMEAs at component level, system level, vehicle level, and then we keep updating them on an application. It's a very, very rigorous process. In my experience of 30 years in auto industry, it's coming very close to, I would say, aircraft industry, where the safeties and the design standards are maturing higher and higher. And I believe that is going to be good to the consumers as well.
Thank you, Mahesh. Still, if we talk about electrification, that has started at fast pace. We have seen three-wheelers where we have a very higher range of adoption. Samir, just want to understand the fundamental questions from you. How do you think the solution to anxiety, affordability, infrastructure, battery management system, BMS, has become? These are the core, concerns that the people or the consumer, the user of electric vehicles are trying to find answer to. Also, the source of energy. We have seen even in recently in UK Parliament, there was a question raised: how much of electric it will be consuming? Do we have enough supply of electricity? How are you going to address these challenges when we imagine the future of mobility or reimagining the mobility? These are the core concerns that comes from all corners.
Thank you, Nabil. So I think I'm just going to first summarize what you just asked. There are 4 deterrents to making great progress in electrification. First and foremost is the batteries today. I'm going to start with India and then go India out, right? So first, the batteries in India are not made in India. Hopefully, people are talking about 2023, where mass scale, batteries will be made. So these are essentially imported batteries that you're learning that your BMS system, whether they are Indian BMSs or BMSs that you get from outside, they have to marry and have to make sure that you completely understand your chemistry well, and you inform the rest of the system, your EV powertrain system, so that none of these issues that you have just spoken about come about and become real, right? And they are detected early. So battery having, in any country, having the right kind of batteries or source of power, let's put it that way, is critical. You can't keep importing it forever. The second thing is your charging infrastructure has to be, adequate. The third one is the grid. Is the grid going to be good enough? People have spoken about 5 crore or 50 million electric vehicles by 2030 in India. These are predictions that have been made by study reports, and they've spoken about at least 4 to 5% of the charging infrastructure has to be there for 50 million. So you can imagine the number of charging stations that are needed. And finally, financing, because even today, the banks and NBFCs, they do not finance, they're not giving the appropriate finance. They're giving 20% interest, higher down payment, etc. So let's talk about the charging infrastructure first. Yes, it's going to require a concerted effort between state governments, central government, people who are making these charging stations, and technology, because technology is also changing, to ensure that you have at least the right number. If not the right number, you have 50% of what you need. But according to me, and I'm very passionate about this, we really need to move very fast to what I call green to green, which is, you just can't take fossil fuel based energy and put it in an EV and say you've solved the pollution problem. And which is where, we need to push, again, through the central government and state government and private companies and PLI schemes. We need to push more and more, solar and wind-based experiments going directly into battery for storage or directly into the, vehicles, if possible. Or, in fact, have solar-based, panels on cars which will electrify them directly. So I think these experiments need to be hastened, not just electrification of cars and battery infrastructure. Then we speak about, swapping of batteries. And I'm a big believer that the doors are open in India for new technology batteries such as aluminum air and hydrogen, which will not actually require recharging, which will require replacement and fairly quick replacement. So a whole breed of new, not charging infrastructure, but replacement infrastructure needs to be established. There too, we still need that government push to happen, because we need to see more, we need to learn more, and we need to implement more. So I think these are some of the things. And then finally, the grid. I think the grid, much has been spoken about the fact that do we even have the energy to be able to charge it? I think the important thing to do is to do a comprehensive understanding of what will 2030 look like, or what will the progression of from now to 2030 look like. I think there'll be a lot of discussion around when vehicles are being charged. Are they fast chargers, or are they charging in the evening where the grid requirement may or may not be there? Then there will be harmonic issues. And so it's a whole science that needs to evolve around that, that yet is not cracked. So I'll be honest, I think a lot of work that both the government, private companies, and state governments need to do on charging infrastructure, on grids, and obviously, as the need grows, the banks will definitely follow. And from our point of view, we are looking at all different kinds of battery packs, battery chemistries, and trying to implement as many solutions that are safe in the.
Sorry to interrupt, Samir. We have so many questions from the audience. I don't want to disappoint them. But before I start taking questions, I would like to hear all on the same subject from all of you. I would request if you could answer briefly. How are we going to deal with these challenges that I mentioned to enable mass adoption of electric vehicles in India and around the world? Nick, I'll start with you. No.
Yeah, so just to echo what Samir was just saying, I think actually the critical thing is getting the infrastructure in place. That isn't only going to be funded by government. It's going to have to be a mix of government direction, government funding, and of course, private companies are going to roll this infrastructure out. One point, just very briefly, I read somewhere recently, if there were, I can't exactly remember the number, but if we look at the technology, and there are a number of vehicles that already do this, as well as accepting energy from the grid, they can put energy back into the grid. And the calculation was that, if anything, it might end up being an opportunity. So wind and solar needs to be stored somewhere. With a smart grid, it may be that every single EV can end up being part of that smart grid. So that's an example of what might look like a challenge, but in the end could actually help with a part of our critical infrastructure.
Thank you. Mahesh, your thought.
Hi, Nabil. Yeah, I agree with what Nick, Samir, everybody said. But I have experience which says, like real estate, there are only three factors in EV adoption in India: economics, and economics. You try whatever you say, it's going to be a secondary factor. The primary factor is this. You can see that what's happening in three-wheeler. Three-wheeler adopted not because of anything else but economics. Two-wheeler, you all know that we had a 10K till June 2021. Per kilowatt hour, and the sale was 4,000. You know what is June 22 sale? 42,000. It went 10x just by increasing 50% FAME subsidy. Okay. Now, so India is a very, very economic and what I would say low cost sensitive market. If your petrol prices and diesel prices goes up, I think everything else, people will that nothing has happened in two-wheeler charging infrastructure, nothing happened into a three-wheeler charging infrastructure so big in India in last 1 year. But the adoption has gone 10 times. In fact, three-wheeler is about 50% of adoption of the wholesale. All these are happening just because of economics. Having said that, it's important that you need charging infrastructure. I'm not saying it's not needed. But in India, if you want large mass scale adoption, the only way is to make it economically viable, which has happened in three-wheelers with the current FAME scheme. The FAME 2 has helped higher economic benefit in two-wheeler, a large amount of subsidy coming in, buses buying by by the FAME scheme has helped bus adoption. So it's very clear proof that those FAME subsidies have helped adoption in economics, and it needs for till it reaches about 10%, then legislation can chip in and do whatever you want. Having said that, charging is important. Charging adapts mainly to the segment which are captive or home charging. I think the private cars needs much more public charging infrastructure, which are spread fast chargers and so on and so forth. Like buses is captive charging. We have depots, we will be able to put install charging and we can use it captively. Two-wheelers, three-wheelers is being charged at home. I think these are all the low-lying areas or in India, because India can't afford very huge charging infrastructure or what we talk about like superchargers with 2 minutes, 3 minutes. It's going to put a lot of heavy weight on the grid. It's all good to do research, but it's important when commercially large-scale adoption happens, we make it simple to the customers. Customers can understand, use it very simply and economically.
Thank you, Mahesh. Shashankji, your comment.
Yeah, so I think your question is basically about the key challenges for EV adoption and what we can do about it. So first of all, I think I also feel there are three major factors, as Maheshji said: economics, psychology, and the psychology of economics. That I believe are the three main. I'll come to that very quickly because you said we are short of time. Affordability is one big thing. So we need to look at the battery costs, and that means that you may probably need to make strides in cell chemistry. We also the ingredients which get into the cell making. For example, in 2021, while we came down to $123 a kilowatt hour, in 2022 actually it has gone up to $138 kilowatt, largely because nickel price and lithium carbonate prices have gone off the roof. Second is we need to also do some collaboration with financing and banks, and I think that was mentioned I think by Samir, and obviously we can think of a new solution for ownerships like subscription or leasing. That should be. Second part, for passenger vehicles, range anxiety. And of course, there we need to have more models with higher range. And and now, if you see last 5 years, the average range has actually increased from 150 to 350 kilometers. I'm talking of an average. So we could also, have a mitigation strategy of offering route planning applications or providing, for example, how to maximize the range. That's basically training for the driver. Third, charging infrastructure. I think it has been mentioned. We need to create that charging infrastructure in India. 2030 estimated that we should need about 200,000 charging points in response to the 2 million EVs. I'm talking of passenger vehicle. We need to, of course, provide access to dealer and open charging networks to maximize the charging opportunity, and maybe technology for fast charging. And I think that's also going to come in due time. Finally, battery management. I think offering battery warranty for consumer peace of mind should also help in larger adoption of EVs.
So thank you so much. Let me start by asking the first question is from Ravindra Sonam, and I thank all the panelists who already replied the questions by text. Thank you so much, but I'll still text some of the questions for the interest of the listeners and viewers who want to hear the questions. So first question is Ravindra Sonam. He wants to understand, apart from EV itself, the infrastructure to charge the EVs. Here's the question. Here the question is, at national level, the electricity demand and supply proportion to target implementation of EV. Appreciate if there is an overview.
First is, I think the question understand is, do we have enough power to charge the EVs available? I think there was a study done by 2030. If we have a 30% adoption, all that we need is 3% additional electricity generation than what India has planned for serving EVs. So there is enough generation plan needed for EVs. So availability is not an issue. Second one is on the grid. I think grid is the most important factor in India because grid stability and availability at the last mile is one of the important factors. Now, slow charging can be done, should not be an issue. I think fast charging needs some specific transformers, HT-LT panels to convert and make sure the grid stability and the harmonics are maintained to availability of charging infrastructure. As Nick said, I think we should not look at only consuming, we should also contributing. You all know that India has committed for a solar alliance. We are talking about a huge 500 gigawatt of electricity being done from renewables. We are already close to 20% plus on renewables energy generation in India. And the biggest challenge is availability of peak demand. I think we don't have time of day metering charges for the electricity. Today, it is being consumed at any time, even in peak time at the same rate. I believe it cannot continue for a long time. As Nick said, we need to look at how do the EVs play to stabilize back into the grid. V2G, G2V has to be done to see how it can contribute to the stability of the grid rather than just consuming. I think these are all the areas which will help to stabilize the grid and the challenges we face. I think it's being recognized by government, industry, everybody, and we are all working towards it.
Thank you, Mahesh. I'll take next question is for Samir. As you have stated, if the battery technology, this question comes from Nikita Deshpande. If the battery technology Gen 1 is yet to have better understanding on thermal process, then how come OEMs are rolling out vehicles? Any major upcoming change in certification requirement that you see?
Good question. I think what I wanted to say was that one, everybody is learning, including the authorities like ARAI and others, who are now looking at what needs to be added from a certification point of view to ensure that there's a cast iron, thermal protection, and there's absolute 100% safety. That having said, none of the major OEMs will ever compromise on any DVPR or any design process verification or test verification, and will never do that. But what I meant was that even 2 and 3 wheelers, there are a lot of unregistered people who are modifying at scale and bringing those 3 wheelers and others into the market. Most of the known OEMs don't compromise what they know, but they may compromise what they don't know, which is what they're learning now. And in fact, the government, working with some of these certifying authorities, working with the large OEMs, are re-looking at what needs to happen to ensure safety 100%. But a lot of unlicensed, the problem with some of these EVs are they're fairly simple to convert. And if somebody converts 100,000 of these 3-wheelers, don't be surprised that they don't know what they don't know. And there are a lot of incidents happening. Even large OEMs who are committed to safety are learning today what needs to go more into these battery systems, into these battery management systems, and how thermal incidences can be avoided 100%. That having said, worldwide, there are such incidents. So, one has to learn and one has to ensure that none of these processes are ever compromised.
Thank you, Samir. My next question, this one comes from Kaushik. Nick, this is for you. What is the addressable opportunity for Tata Elxsi in this segment? And how would Tata Elxsi be placed versus competition?
Well, we've got a long track record of working in the EV segment, as I mentioned earlier on, whether that's battery packaging, developing new platforms, battery management system, thermal analysis, and so on. So actually, our team is growing pretty rapidly. We're focusing on a lot of training for many of our designers and engineers to be able to do the kind of analysis from a digital viewpoint that's going to help our customers move forward. So yes, the team within Tata Elxsi, and it isn't just the mechanical part of it or the packaging. I've already mentioned the software part of it. We're working with multiple OEMs globally. I can't give you a number in terms of what the addressable market is, but I guess everyone's aware that as a company overall, we continue to grow very rapidly, and a very large part of what we do from a design and engineering service viewpoint is indeed focused on EVs, and not just powertrain, but development of UI, UX, development of infotainment systems. So the landscape for us is only getting bigger.
Thank
if
you.
that answers the question.
Thank you, Nick. Samir, next question for you. This comes from Prasad. Is battery self-degradation a concern for adoption of EV by OEMs? And if it is, what are the solutions that OEMs are exploring?
Look, batteries will degrade. Better batteries will degrade lesser, but we've got to learn how to reuse batteries in secondary applications. But more importantly, there will be aluminum air batteries which will degrade very fast. But they don't have any rare metals, and you can reuse the aluminum, etc. So I think the question really is that has the government working with the OEMs and all the stakeholders, have they worked out completely disposal or reuse policy, and is it being implemented? The answer is yes. The answer is there's a whole system out there now to look at what happens to degraded batteries, and the batteries don't degrade that much. Even after 3-4 years or 5 years of use, they may degrade to 80%. You may have a secondary life for them, and you may be able to use them. But there is a process of extraction of the metal, what is usable. There's a process of completely disposing of safely battery systems, batteries and cells. And so this whole thing is being worked out, and there's actually a policy around it. I wouldn't be that concerned, though.
Thank you. Next question for Shashank. Yeah, you want to add something, Nick?
Yeah, just really, really quickly. As of today, what is clear is that super rapid charging doesn't have a great, it can cause degradation of battery. So one of the things that in this whole mix, one of the things that we need to do is educate consumers on the balance between overnight charging, the amount of range that they need, and how frequently they do rapid charging to keep the batteries from degrading unnecessarily.
Thank you, Nick. I'll take one or two more questions. Shashank, for you, there's a question. How do you see battery swapping working in four wheels?
Battery swapping in four wheels is being studied, but I think it's going to be difficult for the simple reason that the batteries, current architecture that is being used, have big batteries at the bed of the floor bed. Difficult to take out or remove, unlike a two-wheeler or a three-wheeler battery. Also, I think on average, the current chemistry of cells enable a battery to be charged 3,000 times in its life cycle. That's about, if you charge every day, so 3,000 days, which is about 10 years. I would not like to swap my battery if I bought it yesterday, the car, I would not like to swap it for a battery which has been run through 3,000 cycles. So obviously, if you want to store it somewhere, you need to store 3,000 batteries or thereabouts to enable an exact matching. It's like that the one-day matches. If the ball goes out of the stadium, then these guys get a box of this thing. If it gets out of the stadium on the 45th over, they get some 5-6 balls around 45 over old, and then it's one of the balls is picked up. So I think battery swapping still not yet clear. I would say it's a little difficult for four-wheelers.
Thank you, Shashank. I'll take this last question from Nimit. And Mahesh, this is for you to answer in regard to increasing adoption of EV. A lot is dependent on data communication, which happens through OTA. But multiple players are offering solutions which are specific to their products. So products only, then they don't have open source offerings. His question is, how do you think it is crucial to have an open system availability to drive data communications?
I think that's a very good question. It needs a lot of thinking, but just to give you a framework so that you will know. If it is a vehicle specific or technology specific data, then it is the right of the OEM to hold and do analysis and do improvements to give back to customers a better product over a period of time. If it is a consumer related data, I think nobody can hold it. I think it's the consumer himself, and we can't track any data or hold any data for them. And it's important that unless he or she consent to use the data or publish the data, we can't use that data by itself. The third is general traffic patterns. For example, how many people are going from Bandra Kurla to, let's say, Andheri every single day in the morning. It's a general data, not tagged to any person, not tagged to any vehicle. Then such data can be really used publicly available. Where the charging stations are available, it is a public data. It can be available unassessed by. So the data has to be segmented into multiple baskets, and these data are being generated by us and many others, including OEM. I think there has to be a framework which has to be made. What can be shared, what should be available in public, and what should be protected for safety and security of personal data, and so on. And there are some frameworks being worked out. Even Parliament have debated, and they are coming up with a new bill, as you know. So it's a very big subject by itself. All of us are learning, and we need to be within the framework of the legislation of the country, like, for example, in Europe as a GDPR and things like that. So we need to ensure that we meet the legislation and create innovation over and top of that layer where we are. And it needs a long work to be done. It's a very good question.
Thank you so much, everyone. Mahesh ji, Samir, Shashank ji, and Nick for joining ET Auto virtual roundtable on reimagining mobility. And I thank all the intelligent attendees who put forth such intelligent questions and enhanced and enriched the discussion level. Thank you so much, everyone, for joining it today.
I'd just like to thank everyone that's joined the panel. On behalf of Tata Elxsi, really fascinating conversation. And in my view, we covered quite a lot of ground in 1 hour on such a relatively complex subject. So my thanks to all of you.
Thank you.
Thank you so much.